So first of all, we will write the system of linear equation in matrix form, okay, in standard matrix form. So whatever the coefficient of the variable, we will write those coefficients. So coefficient of x is 1, 2, 1, 2, minus 1, 3, 3, 1, 2. So first of all, complete this matrix and then write x, y, z equal to 4, 1, 7. So the matrix is written. So this is called A matrix, this is called X, and this is called B. So this is the standard formulation of the system of linear equation. I think you might have studied this formulation in your high school as well. So AX is equal to B. So once the AX is equal to B is there, so your objective is to solve for X. What is X? X is having X, Y, Z. So our objective is to solve for X, which could be written by this way. X is equal to A inverse B. So it means that you need first of all A inverse, then you will multiply A inverse with B to get your X. Okay, so it means that we need A inverse. So we already sorted out the A. We already know the A. A is 1, 2, 1, 2, minus 1, 3, 3, 1, 2. That is A. So what is the technique we were using to calculate the inverse? So first of all, I think the convenient method is to solve by cofactor method. So for cofactor method, what we need is to make the minors. First of all, we make the minors. So let me check 1, 2, 1, 2, minus 1, 3, 3, 1, 2. So to get the minors, so we need M11, M12, M13, and then we have M21, M22, M23, and lastly we will have M31, M32, and M33. So first of all, by using the matrix, we will be calculating M11. So when we are talking about the matrix M, so the order is written by M11. So when we say 1 1, so 1 1 mean exclude row 1 and column 1. So for all the minors, we use the word exclude. Okay, 1 1 mean exclude row 1 and column 1. So by excluding row 1 and column 1, what is remaining? Minus 1, 3, 1, 2. So by solving it, minus 1 multiplied by 2, answer is minus 2. 1 multiplied by 3, answer is minus. Let me make it later. I will calculate this one. Just to minus 3. Why minus 3? 1 multiplied by 3 is plus. Why I am writing minus 3? Because it's a second diagonal. Okay? For the first diagonal, you will keep the sign whatever the sign is, and for the second diagonal, when you move up, you have to change the sign. Okay? And what about M12? M12. Exclude row 1 and column 2. 1 2 mean exclude row 1 and column 2.
Yeah. 2 1 1 2.
So 2 row 1 and column 2. So 2, 3, 3, 2. Okay, 2 multiplied by 2 answer is 3 multiplied by 3 answer is minus 9. We have to keep the opposite sign when we are moving up. Okay, so 3 multiplied by 3 is basically plus 3 plus 9, but we'll take the reverse sign of it. Okay, so the answer is minus 5. So 1, 3 mean row 1 and column 3
2 minus 1, 3, 1.
2 minus 1, 3, 1. So 2 multiplied by 1 is 2, 1, 3 multiplied by 1 is minus 3, so plus 3, very good. So answer is plus 5. Okay, so that is the 3 elements has been completed, and we'll try to complete the rest of the elements by having the, what is, let me write here A again so that,
I no need to do M21.
yeah.
No need. M21 and 22.
Yeah, we will have it. We will have it. So 2, 1, 2, 2, 2, 3. So the matrix A is, I'm writing here just for your reference. This is A matrix. So exclude row 2 and column 1. 2, 1 mean exclude row 2 and column 1. So what is remaining?
2, 1, 1, 2.
2 multiplied by 2 answer is 4. 1 multiplied by 1 answer is minus 1. So altogether we are getting 3. 2, 2. Row 2, column 2. 1, 1, 3, 2. Isn't it? 1 multiplied by 2 answer is 2. 3 multiplied by 1 answer is minus 3, minus 1. Okay? 2, 3 mean exclude row 2 and column 3. So column 3 and row 2. So 1, 2,
3, 1.
3, 1. 1 multiplied by 1, 3 multiplied by 2 is 6, minus 6, minus 5. Okay. Now we are moving towards calculating M31, M32, M33. Okay. Again, I am writing matrix A for your reference. 1, 2, 1, 2, minus 1, 3, 3, 1, 2. That is A. So 3, 1 is exclude row 3, column 1. So 2, 1, 2, 1, minus 1, 3. 2 multiplied by 3 is 6. 1 multiplied by minus 1 answer is plus 1, minus 7. Exclude row 3 and column 2.
1, 1, 2, 3.
1, 1, 2, 3. 3 minus 2 answer is 1. Okay. And 3, 3. Column 3, row 3. 1, 2, 2 minus 1. 1 multiplied by answer is plus minus 1. 2 multiplied by 4, 2, 2, 4. Minus 4 answer is minus 5. Okay. So now we will collect all these terms in a minor matrix. So we will denote a minor matrix, and in minor matrix we will write all the values we have calculated. So M11 will place here, starting from M11, minus 5, minus 5 and 5. Minus 5, minus 5 and 5. So why I am writing in term of row, in first row? Because M11 this is M12, this is M13. Okay, that's how we try to complete. 3 minus 1 minus 5. 3 minus 1 minus 5. 7 1 minus 5. 7 1 minus 5. Okay, so once the minor matrix is completed, now we will write a C matrix. Okay, and C matrix is basically, we simply write whatever the M matrix, we simply write all the values in C. Whatever the values we have in M, we will write in C, just to change the sign of the odd positions. Change the sign of the odd positions. So minus 1 existed at M11 place. So when we are adding 1 plus 1, so number is even. So it means that minus 5 will remain the same. Okay, and for the second element, which is minus 5, the location is 1 2. So when you add 1 with 2, so you get odd number. So when you are getting odd number, then you have to change the sign. Okay, and 5 is located at 1 3. So 1 plus 3, 4. 4 is even number. So 5 will remain as it is. 3 is existed in which location? 2 1. So we will change it, minus 3. Minus 1 will remain as it is, because 2 2, it is existed in 2 2. 2 plus 2 is even. Minus 5 will change the sign. Yeah. So because it is 2 3. And 7 will remain the same, because 3 1. And 1 minus 1 and minus 5 will remain the same. Okay, so that is called the C. Okay, we change the sign, we change the sign for odd location. Okay, we change the sign for odd location. I have just written for your reference that you will understand it. Now once you have the C, then you have to take the C transpose. Okay, so you have to take the C transpose. C transpose is minus 5, 5 and 5. So I am writing a row into the column. So minus 3, minus 1 and 5. 7, minus 1, minus 5. So that is how we take the transpose. By changing rows to the column or column to the rows, you will get the same answer. That is called the C transpose. So almost the one major part has been completed. Now to calculate the inverse, just we need the A determinant. Okay, determinant of A, which is equal to A11 M11 minus A12 M12 plus A13 M13. Okay, A11 is the first element existed in first row and first column. A11 mean. So what is A11 from matrix A? So we have the matrix A is here. So what is the first element? 1. Okay, and what is M11? Minus 5. Okay, so whatever is needed we have already. So 1 multiplied by minus 5. A11 M11 minus A12. So A
Minus or plus.
minus
Minus or plus.
which one?
After A1 M11.
M11 is minus or plus? You mean?
No. After A11 M11.
M11. Yeah, it is whatever we have calculated M11. We have calculated M11 here. But M11 is minus 5. Okay. So we keep the same, whatever M11 is, we keep the same. Okay. A11 multiplied by minus 5 is M11. And A12 is 2. What is M12? Minus 5. And A13 is 1. And 13 is 5. So we have minus 5 plus 10 minus 5 plus 5 minus 5 will cancel. So we are remaining with 10. So A determinant is equal to 10. A determinant is 10. Now the inverse is 1 over 10 into C transpose. This is called the A inverse. 1 over 10 mean determinant. Let me write in the form of this one. 1 over the determinant into C transpose. So we have already 1 over 10 and C transpose is here. Minus 5 minus 3 7. Minus 5 minus 3 7. 5 minus 1 minus 1. 5 minus 1 minus 1. And 5 minus 5. 5 minus 5. Okay. So that's how we have calculated the inverse. Okay. Now this inverse will be used to calculate the system of linear equation. So we already have written that A inverse into B is the formula that will be used to calculate the x. So in x we have already x, y, z, all the values. So A inverse is 1 over 10 and minus 5 minus 3 and 7. 5 minus 1 minus 1. 5 minus 5 multiply by B, which is equal to 4 1 7. Okay, that is called x. 1 over 10 is outside. Now you have to check the condition. How many rows and columns we have? 3 rows, 3 columns. How many rows we have? 3 rows and 1 column. So what is the condition? The number of columns in A must be equal to number of rows in the second. So it means the multiplication is possible. So now we multiply row with column. So 5 multiplied by 4 minus 5 multiplied by 4, answer is minus 20. Minus 3 multiplied by 1 is minus 3. And 7 multiplied by 7, answer is 49. Now we are moving to the second row. 5 multiplied by 4 is 20. Minus 1 multiplied by minus 1, minus 1. Minus 1 multiplied by 7, minus 7. 5 multiplied by 4 is again 20. 5 multiplied by 1 is 5 plus 5 and minus 35.
Mister, can you repeat this?
Which one?
This one.
So we are multiplying row with column. So this row, first of all, multiply by this column. Minus 5 multiplied by 4, minus 3 multiplied by 3, 7 multiplied by 7. So we got this one. And for the second one, again we multiply with the same, we'll get this one. And for the third one, we multiply third row with again with the same column, we'll get this one. Okay. And now we'll try to add or subtract whatever the, so minus 3 minus 20, minus 23 and 49. What is the answer?
Minus.
Minus 23 and plus 49 is 26 something. Hmm? 26. And 20 minus 18, it is 12. And 25 and minus, so minus 10. Okay, you know, simply need to divide 26 by 10, 12 by 10 and minus 10 by 10. What is outside we have moved inside. So it is 13 over 5, it is 6 over 5, it is minus 1. Okay, so that's what we have obtained. X is 13 by 5, y is 6 by 5 and z is minus 1. Okay, so we can write here x is 13 by 5, y is 6 by 5 and z is equal to minus 1. That is the solution of the system of linear equation. Okay, so that has been calculated through the inverse method. Before we have been using the row operations, so now we have used the inverse method to calculate to solve the system of linear equation. Now I'm stop recording.